Hello, it's Keith here, and we've got a super special episode today. We're going to be learning how to use the stereoscopic shutter glasses of the Sega Master System. And because I'm an incredible 3D nerd and I get off messing with weird hardware, we're going to be shooting today's episode in 3D. So if you have a set of paper anaglyph 3D glasses, these red-blue things, then put them on. I, however, have these, so I will be wearing these, and you'll be not looking as cool as I do right now. Oh yeah. So let's go over and have a look at today's episode. Okay, so here we are. We should be in 3D now. Ooh, I'll stop doing that. Okay, so today's episode. Well, we need to discuss the concept of how 3D works a little bit and how it can work with shutter glasses and how the games will create a 3D image. Now, the glasses that this episode uses are the crude anaglyph glasses. These use two colour filters. There is a red filter and a blue filter. Now this is all to do with light theory because the light is made up of red, green and blue. The blue filter is actually cyan and that's letting green and blue through, but it will not let red through. The red filter will let red through, but will not let green or blue through. So this is splitting the three colour channels into two separate images, and this allows a normal screen, like the one you're looking at today, to produce two images for each eye. And we have to give each eye a slightly different image to create the 3D image, and that's how we're doing things. Now the setup I'm using today, I'm using a pair of web cameras. I've aligned them properly and I've got colour filters on. So one image is filtered to be cyan, that's green and blue combined, and one image is filtered to be red, and then the two are being overlaid over each other. So I'm using two physical cameras to produce two separate images and the splitting of the red, green, blue colour channels to create the two images for the eye. And because the cameras are physically apart from each other, they're literally parallel to each other, you are creating the two images that your eyes, which of course also physically apart from each other, would expect to get. And depending on the distance the cameras are, the image will become more 3D, and that's why if I move my fingers closer to the camera, it starts to get closer to you and will start to hurt your eyes, which is something you do need to bear in mind when it comes to producing 3D images. The emulator we're using today, the Dego emulator, does not support true 3D. I mean true 3D in the sense that the shutter glasses would allow a full colour image for each eye. These crude anaglyph glasses that I'm wearing right now, they aren't true 3D in that sense. The 3D is true, but the colour is lost. We're losing a lot of colour information, which is why I've had to make a lot of things grayscale to keep things nice and comfortable. And that's why my text is no longer read on my website for this episode. So the Dego, it gives us great 3D, but we aren't getting the full abilities of the Master System because the Master System could have done true 3D. The way its shutter glasses work is it doesn't use colours to filter different images to the eyes. It uses a liquid crystal display. Now that's like the things on your simple watches that they go black or they go clear, or if your LCD games, your Game & Watch kind of thing. And what they do is there's one on each eye. They're controlled by the computer, the Master System in this case, and they can be set to black out one eye at a specific time. And because the LCD is very fast, they do this at 60 Hertz. Effectively, what they're doing is the Master System is showing one eye image alternating, so shows left eye image, right eye image, left eye image, right eye image every single frame. Half of those frames are blacked out to the left eye, and the other half are blacked out to the right eye. So both eyes are seeing a different image. The point of this is that we need to program our game to alternate between the two views of the game scene to give the viewer a 3D image via those shutter glasses. And what we're going to need to do to achieve that is we're going to need to move our objects around the screen to make them into 3D so that the human eye interprets these as a 3D object even though the screen is physically flat. Now I think anaglyph glasses are actually quite handy to do this because if you're looking at this website you don't need the glasses. You can easily see, and in some ways it's actually easier, you can easily see how two images that are two-dimensional and can be interpreted by the eye as a 3D image. Now if you've not got the glasses you'll be able to see everything fine and we'll describe it, but if you've got the glasses I suggest you take them on and off and just have a look at what the images actually look like so that you can understand how things are actually being converted from a 2D image relative to the two eye positions into a visual 3D object. But I'll describe them if you don't have them. Okay, so we've got our first example just here. Now let's just take the glasses off here. So you'll see here that there's two versions of this image here. So the red one here will be seen by the left eye, and the blue one here will be seen by the right eye, and they're slightly overlapped. Now, if you've got the glasses, you can maybe tell you'll need a big screen to do it because screen size does make a difference to how much things stick in and out. But that is actually sticking out of the screen. If we move down just a little bit, now I'll just move along just because I'm zoomed in a little bit too much here. Now you can see here there's multiple versions of this image, and you can see that the relative positions of the left and right versions are different, and depending on the relative positions, the visible position of the image in 3 dimensions, whether it sticks out of the screen or goes into the screen, is changing accordingly. So this top one is the furthest out of the screen in this set. This one is slightly out of the screen. My mouse cursor is making my eyes hurt, to be honest, because it's going through the image, which is one of the things you have to be careful of and why sometimes you'll have discomfort in the 3D cinemas. This one is exactly sort of flat with the screen. This one goes slightly into the screen, so my mouse cursor over the top of that is not uncomfortable. And this one goes far into the screen, so my mouse cursor seems quite far in front of that. And I said about you've got to be careful with 3D. If you're in a cinema, for example, and there's something sticks far out of the screen, but it sticks so far out of the screen that visibly it should be in front of the seats or something, you know, it physically, logically doesn't make any sense anymore. That will be very uncomfortable for you. And that's why if I put my mouse cursor over this one here, logically it's impossible because the mouse cursor is behind an object that the 3D is telling your brain it should be in front of. And this is also a problem when it comes to making objects stick out of the screen. If I put my hand in the middle of the screen, that'll be quite comfortable, but if I put it at the edge, because part of the 3D information is actually off camera, so to speak, it will become uncomfortable. So things sticking out of the screen you would always want in the middle, and you always want to make sure your layering is correct and everything is going to make logical sense when it comes to sort of the way the two images need to combine to create a 3D image. Okay, so as I say, all we need to do to create 3D images is show the left and right eye a different image, moving the objects to simulate 3D depth. That's the simple bit. The next simple bit is how do we control those shutter glasses? Well, the shutter glasses are literally just a pair of black filling objects, you know, they're just a giant LCD effectively, and we have very simple controls to control them within the Sega Master System. They're mapped to a hardware port FFF8, and this has just a single bit effectively controlling it. The low bit of that address, if you pass it a 0, the right eye will be able to see, the other eye will be blacked out, and if you pass it to 1, the left eye will be able to see and the right eye will be blacked out. Now this address is actually overlapped by the memory mirror, so there is a clone of the memory there, and so when we write to that, it will write to the equivalent address in memory. If we read from it, we will be able to read the last data we sent to the shutter glasses from that memory address, but we can't physically read the shutter glasses, and curiously the Sega Master System can't tell you if shutter glasses are connected, which is quite handy for me because I've bought the 3D games, I've not bought the shutter glasses, so you can probably guess there's going to be a 3D live stream on my live streaming channel at some point, which is why I've spent 5 effing hours getting these cameras set up and getting all this hardware working, because apparently connecting 2 of these USB cameras to even the same hub doesn't work, and I managed to break a camera in the process, but that's another story. Anyway, I think my commitment to 3D obsession is probably confirmed at this point, so let's just move on and continue discussing this thing. So, as I say, the important thing is we have got to produce 2 completely separate images for the eye, and we've got to be able to do it extremely fast at 60 Hz. Now, our game might be a bit slow, and that might be unrealistic for sort of drawing, so what we're going to have to do is we're going to have to cache, make a buffer in memory of all the objects we want to have on the screen, for the left eye and for the right eye, and then during the interrupt handler we're going to have to fast copy that bank of information into the visible information so that we can quickly flick, keeping that frame rate up, that 60 FPS that we've got to get working for the shutter glasses to physically function. And then we will actually be able to sort of take our time defining the positions of the objects as however fast our game requires, but the shutter glasses will be happy because they'll be getting their constant changing 60 FPS. Now what we're going to do in these tutorials is we're going to create a simple tile map using our previous Chibico simple tile map example. It's been converted for today's lesson, and we're going to make a cache of the tile map location, the data in the tile map, the position of each tile. We're also going to create a simple sprite, and we're going to cache that as well. So we're going to need a cache of the tile map and the sprites for the left eye, and a cache of the tile map and the sprites for the right eye, and we're going to have to quickly transfer them during every interrupt. So we're going to modify our sprite routine, modify our tile map setting routine, and then we're going to create an interrupt handler which is going to shove that data into the tile map and sprite data that's live on the screen, and going to flip the eyes of the shutter glasses accordingly, and that's going to give us our 3D image. And we're going to be able to see that 3D image not with shutter glasses because we haven't got them, and our emulator doesn't support them, but with our good old trusty red cyan glasses. So that's what we're going to be doing. Okay, well, enough chit chat. Let's go over to our code and let's see it in action. Now, at this point, you might want to take your 3D glasses off because this bright image might be a little bit uncomfortable. I'm going to take mine off right now. Okay, so returning to reality, let's carry on. So what we've got here is our code. Now, first of all, let's have a look at our tile and sprite routines. I'm not going to go over them in massive detail today. I'm going to assume you've actually seen the previous tutorials on sprites and tile maps. If you haven't, please go back and have a look at them as well. We're going to cover them just very quickly here. So what we're going to do is we're going to create a version of our fill area with tiles. This will fill a consecutive grid with our Chibico characters tiles. Now, in the past, what this did is it wrote to the VDP, but now we can't do that. We need to write to the buffer instead. And if we look at the top here, you can see there's a brief description here. We're going to use the memory address C000 to C5FF for the left eye tile map and C700 to CCFF as the right eye tile map. Now, when we use these functions, we're going to have to tell them what tile map we want to set. They're designed to work with a cache, not an eye, so we can't run the routine and say, draw it at this Z position or draw it on the left eye. We have to pass it in the memory address of the tile map we want to alter in RAM. So IY is going to be the start tile here. IXH is the top byte of the tile map, so the beginning of that tile map. And what we're going to do here is we are going to be writing into a memory address which is retrieved from this new get cache screen pos, which is almost the same as before. Before we were using out commands to select our address in VRAM, and we were using out commands to write data to VRAM, but now we're using standard load commands because we're writing to the cache in memory, and we are loading them with DE here. So IXH is added to D, which is the top byte of our destination address. This is the same offset calculation to calculate a position in the tile map. And then we're just copying the tile numbers into the tile map into DE here. We've had to change to IX for our start tile because we used to use DE for that. We need DE for other things this time. So we're not able to do that. So this will actually draw our tiles. Now, our Chibico character is a 48 by 48 image that's been split into tiles, and you can see here we're drawing at position 0303 and 6 tiles wide and 6 tiles tall, starting from tile number 128, and we're drawing it twice. Once we're drawing it with the address as C7, which is the right eye tile map, C7000, then we're writing it again, but this time you can see we're changing X position, moving it to the left by 1, and we are writing it XY0203, same size, same tile number, and this time we're writing to the left eye tile map at C000. Now, it's important that they're parallel. You don't want to have, if we did something like change the Y position, that your eye might be able to figure that out, but it'll feel like your head's at a tilt or something. It won't be comfortable, so you really always want them to be parallel and just the X offset to be changed. Now, in this case, if we run this, the image will appear like it's going into the screen, but if we change this to 04, that should make it appear like it's coming out of the screen. Now, we'll have a look at these in just a second. Now, onto the sprites. We're going to be drawing our crosshair image that we've used before. We've got a routine called draw crosshair because it's actually made up of 4 separate 8x8 sprites. Here it is. It's using this set hardware sprite command, and we're using the command twice again. Now, the buffer for the sprite cache for the left eye is at C600. The right eye is at, where is it? CD000, and we're loading that into IXH just here. And you'll see there's a bunch of extra code here, and this is because we're going to move the right eye image, and we're going to see how that affects the stereoscopic 3D. I'll describe it to you. If you've not got the glasses, don't worry about it. You'll be fine. You're probably actually far more comfortable if you've not got the glasses. So as I say, it's just a bit of fun. I do enjoy playing with the 3D. So as I say, you're not really missing out if you don't have those 3D glasses. So where are we? So here's our set hardware sprite command. Now, if you've seen it before, all we're doing is we are calculating the offset of the sprite we want to change this time within the cache. And then we are writing the Y position, the X position, and the tile number. Again, if you're not familiar with the sprites, then you want to check out my sprite tutorial on the Sega Mastersystem before you come to 3D. 3D is a little bit adventurous if you don't know how to do sprites, but it's certainly a lot of fun. Okay, so that's going to set our hardware sprite. And that's what's going to do the work of getting that cache ready. Once the cache is ready, of course, we need to get it sent to the actual screen, and we need to flip those shutters. Now, we've got our interrupt handle defined here at RST7, hexadecimal address 38, which is the interrupt mode 1Z80 interrupt handler. This will actually occur every frame if we set it to. To do that, we need to make sure we set up our registers correctly here. I believe it's this bit just here that turns on the interrupt, the V-blank interrupt. So that will allow us to have a routine run at RST7, 38, hex 38, every time the screen starts redrawing. And that will jump down to here. Now we're using the shadow registers here so that we can quickly switch everything over. And what we're doing first is we're flipping the eye here. This will actually flip between left and right eyes. And then what we're doing here is we're jumping depending on which eye we're showing, and we're going to copy over the correct contents of the cache to the visible screen accordingly. Now the code is actually almost exactly the same in both cases, but never mind. Now here we're clearing the interrupt. Now if we don't read in from VDP control, the interrupt will not think it's been processed, and it will keep firing over and over again forever. So if you forget to do that, your machine will lock up. So that's very important. Now our right eye and left eye routines are basically almost identical. All it is we're setting our destination address as first the tile map and our source address as the cache for the right eye here, but the left eye just here. We're then doing a sequence of OTIRs. We're setting B to 0, which effectively means it's going to run 256 times, and we need to do many OTIRs to fill the entire tile map. Now, you could unwrap this a little bit maybe. There might be a slightly faster way of doing it, but this is fast enough. We only needed to get the 3D image transferred within the V-blank. If you had sound and things, you might need to be a bit more efficient at things, but this is adequate for me. So this is copying the tile map for the right eye. This is the tile map for the left eye. This is the sprites for the right eye. And this is the sprites for the left eye. And once these are done, we just jump back up to the top here, clear that interrupt and return. Okay, so that is how we're able to transfer the data to the ShutterGlasses very quickly. That's how we're able to create our caches. Let's put our 3D glasses on now and let's see the results in action. Okay, so if I now just press F6 here, and if we just minimize this down. So I've minimized this down to a reasonable size here. Okay, what we do need to do though, if you have got those 3D glasses, is we need to make it as big as we can, because the size does make a difference to the 3D effect. Okay, so the Chibico character just here is appearing slightly into the screen, and this cursor, this crosshair here, is going in and out of the screen. Now, when the two images overlap, it's effectively flat onto the screen. It's now going into the screen and out and in and out and in. So it physically looks like it's coming into and out of the screen if you're wearing the 3D glasses, and it would look the same if you had the shutter glasses. And that's how the 3D effect works, and that's how we can control how much our 3D objects come out of the screen or go in accordingly. Now this Chibico character here looks like she's going into the screen, so she looks like she's behind the flat screen itself. Now if I change the code, if I go down to here and I change this to 5, it used to be 3, it used to be 2, sorry, and I change this now. Well, it now looks like it's sticking out the screen quite a lot. Actually, that's a little bit uncomfortable, and that is an important thing to bear in mind. If we change this to 0, for example, here, well, now it would, in theory, if I make it really small, maybe, yeah, I can just about focus on that. I'm on a 4K 30-inch monitor. I can just about focus on that. But if we make this too big, it's going to become, the stereoscopic depth is going to become so great that my eyes are going to possibly hurt. Well, I can just about focus on that. We'll probably get it off the screen though, because I possibly have. I've been doing this quite a while, and I tend to be able to focus on quite deep things. So maybe that's going to be a bit uncomfortable for you. I certainly wouldn't recommend doing it. The point I'm trying to make is the depth, in theory, you can make things very, very deep and stick out an awful lot, but you need to bear in mind the sort of health and safety and comfort of your viewers, which is probably why I'd better get this off screen pretty quick. But you don't want to make things too 3D Otherwise, there will be issues. And also, this wouldn't be true with real shutter glasses because they're full color. But with anaglyph glasses, as you've probably seen on my today's demonstration, you probably want to desaturate things, because anything that's bright red, the right eye wouldn't see, and anything that's bright blue or bright green or bright cyan, the left eye wouldn't see. So try and blend things a little bit and use colors that have combinations of both. I've gone ultra extreme and made everything almost black and white. You can see my images on the side here have changed quite a lot, and that was to do that. Okay, so there we go. That's a bit weird, I know. I thought it was a bit of fun. As I say, I really enjoy playing with 3D. I think it's a fascinating way to make things a bit more unusual and a bit more challenging relatively simply. You know, you can literally go into another dimension just with these old machines and just sort of 2D pixel art, really. So I hope you found this amusing. I hope your eyes aren't hurting from all the 3D, and I hope you've not hurt yourself laughing at my 3D glasses. Anyway, whatever you do, maybe have a go with the 3D, or at least download some of the 3D games and try them on the emulator. But have a lot of fun with the Sega Master System. Thanks for watching today, and goodbye.